In the last couple of videos, we looked at parabolas and graphs, what we had to do to get the graph, what we had to find. In this video, we want to look again at a parabola, but we want to use some basic calculus. Now, if you talk to students that have taken Calculus 1 or Calculus 2, and you ask them what is calculus all about, what comes to mind when you hear the word calculus, they might tell you limits, continuity, the derivative, differentiation, integration. They might mention the antiderivative, applications, hard word problems, area under a curve, volumes of solids or revolution, and a bunch of other things. But the very basic thing about calculus is the idea of slope, instantaneous rate of change. And that's how it starts. You start with basic limits, and you come up with a lot of formulas. Some people would say there's only two types of calculus problems. That's it, two. The derivative and the antiderivative, or instead of antiderivative, they might say integration. And some would say there's a lot more than that. Here, though, we're going to look at the very basic concept. And if you haven't taken calculus, you probably won't understand this, but at least you know the idea of parabolas. So here we want to find the equation of the tangent line to the curve y equal x squared minus 4x plus 7. The calculus involves computation that is called the derivative. You know about the derivative when you deal with linear functions, or when you're graphing lines, you can find the slope of a line if you know 2 points, or if you have the slope-intercept form, you can find the slope of the line. So for this one, again, this is just introducing you to basic calculus. In this case, we're looking at the derivative. So for this one here, the derivative of this, and there's several ways to denote it. I'm just going to put a prime here. This stands for the derivative of this function y, which is a parabola. The graph is a parabola. The way it works is 2 times the coefficient here is 2 times 1, and then you subtract 2, or subtract 1 from the exponent there too, so it becomes 2x. When you can continue again, this is the formula, the concept for polynomial functions. Here 1 times minus 4 is minus 4, and then we subtract 1 from the 1. Gives me 0, x to the 0 is 1, so that just gives me 2x minus 4. And the next time we do the same thing. Remember, this doesn't have an x, so if I follow the same rule, this x to the 0, 0 times 7 is 0. So if it's constant, the derivative is just 0. The derivative of any constant is 0. The derivative of 7 is 0. The derivative of negative 6 is 0, and so on. So this is what we call the derivative of this. Now what does that give me? This actually gives me the slope at every point on this graph for the line that touches the graph at that particular point. So notice, if I take a typical parabola that opens up like this, or it could open down, same idea. I'm going to draw a tangent line right here. So right at the vertex. Whatever that vertex is, doesn't really matter. Let's say I draw a line tangent to the parabola at that point, at the vertex. Then what would be the slope? Without knowing any calculus, what would be the slope of this line? Let's call it m. What would be the slope of this line right here that touches the curve of the parabola at the point right there where the vertex is? So if that's the origin, the vertex would be 0, 0, but it doesn't have to be at the origin. It could be way out here, over here. Well, we know that horizontal lines have a slope of 0. Vertical lines have no slope, or the slope is undefined. If a line is slanted this way, or going up, the slope is positive. If the line slants or comes down this way, the slope is negative. So I can use this formula to find the slope of the line tangent to the curve at any point that I want. So now this one says find the equation of the tangent line to the curve, this parabola right here, at x equal 1. So that means this is my slope formula now. I use the derivative, that's calculus. Okay, if you haven't had calculus, that's okay. This is just to introduce you to it in case you decide or have to take it. So this becomes a function now. This becomes a function, a derivative or a slope function. I can find the slope at any point. So if I plug in a 1 right here, that gives me, where the 1 there? It gives me a 2 minus 4, that's be negative 2. So this tells me that the slope of a line that's tangent to this curve at x equal 1 has a slope at negative 2. Now because the slope is negative, I know the line has to come down this way. If the slope had been positive, I know it's rising. So it's going to be somewhere over here, and it's going to come down this way, touch the curve at the point where x is 1. Okay, so well, we want the equation of the line though. So we need a point. Well, we know we want it where it touches a curve at x equal 1. Well, if it touches a curve at x equal 1, what's the y component? Well, x equal 1, just plug it into the function. 1 squared is 1. Here, that's 1 times minus 4. That's 1 minus 4 is negative 3. And 7 gives me 4. So now I know the slope and I know a point. Find the equation of the tangent line to the curve. So we know it's tangent at x equal 1. And we know the slope at x equal 1 is negative 2. So using the point slope form then, we just go 1, y, the point is 1, 4, y minus 4 is equal to, slope is negative 2, so this will be negative 2. This will be x minus 1. And this is actually the equation, but sometimes I might ask you to put it in slope-intercept form, so let's just solve this for y. So if I solve this for y, this will be a negative 2x here on this side. And then negative 2 times the minus 1 is a plus 2. And then bringing the minus 4 over, plus 2. And a 4 gives me 6. So at the point where x is equal to 1, which actually gives me the point then when I put 1 in for x, I get 4. So this line right here passes to the point 1, 4, which is on the parabola. And that line has a slope of negative 2. And that's really all we need. We don't really need a graph, but just to give you an illustration of this, I have this drawn out over here. Of course, in another video, we looked at how to find the vertex of this. This is a vertical parabola because it has the x squared, and it has a positive coefficient here, so it opens up. So let's do this. I'm going to do this the way we did it in an earlier video. I want to complete the square in x. So x squared minus 4x, the coefficient here is 1, so I take half of minus 4 is minus 2 squared, I get 4. I added 4 to this side, so I have to add 4 to the other side also. And I'm going to take the 7 over, so that's going to give me a minus 7. And because I added 4 here, I have to add it over here. So this becomes then y minus 7 and 4 is minus 3. And over here we got a perfect square, kind of like the video we did earlier. So this becomes x minus 2 times x minus 2, or we write it in the standard form x minus 2 squared. So this would be x minus h and y minus k. So the vertex for this one is going to be at 2 and 3. And the parabola opens up. So now we have the vertex. Because I have the formula for the derivative, let me show you another way you can get the vertex here. We know that the derivative, we just looked at this, the derivative of this was 2x minus 4. And remember the tangent line at the vertex, we notice if it opens up or opens down, a tangent line at the vertex is going to have a slope of 0. So if I set this equal to 0, I want to know when is this equal to 0? 2x minus 4 is equal to 0, of course, when x is equal to 2. So it's tangent at the vertex, and that's at x equal to 2. So that tells me that the first component of the vertex is 2. Now I just need the y. Well, you put 2 into the original function. 2 squared, 4. 2 times minus 4 is minus 8. 4 minus 4. 4 minus 8, rather, is negative 4. And 7 gives me 3. So that's another way to get the vertex. So you have a regular parabola, solve for y in this form. Find the derivative, set it equal to 0, and that gives you the first component of the vertex of the parabola. Then you just plug it in, and you get the y. But like I said, you have a way to get the vertex. You don't need the calculus at this point. Anyway, this is the parabola right here, and the vertex is here at 2, 3, and the tangent line passes to the point 1, and then 4 up. So we go 1 over, and right there, 1, 4. So the line would go something like this. Touch the parabola at that point like that. It only wanted the equation of the line, but this is what it looks if you go ahead and graph it along with the parabola. There's another line tangent over here somewhere with a positive slope, and of course the line that's tangent right here at the vertex, that of course has slope of 0. Thanks for watching. We'll see you next time.